Hi friends, welcome to our channel RF Design Basics. Today I came up with another HFSS tutorial on antenna design. I am going to show you step-by-step process of designing a microstrip antenna at 2.4 GHz. So for microstrip antenna design, we need to design three structures. First is ground, then substrate, and above the substrate patch. So I will design the ground first. For designing ground, I will draw the rectangle. I am taking the symmetrical structure here. So I will rename it as ground. I will change the color and go to create rectangle. The size of the ground I am taking as 60 by 60 mm. So starting point I am taking as -30, -30 and 0. And X size is 60 mm and Y size is also 60 mm. Fit the view to the window. So this is our ground structure. And now I will design the substrate. For designing substrate, I will take a box, rectangular box. So start from the same point, move in the XY plane, and then move in the Z axis. So click on box 1 and rename it. This is substrate. And material we will give FR4 since we are using the material FR4. Go to edit the material and type it here FR4. FR4 epoxy we will choose. So this is FR4. Okay. Now go to create box and change this Z size to 1.6 because the height of the substrate is 1.6 mm. Okay. So this is our substrate and this is our ground. Now we will design the patch. For designing the patch, we will take another rectangle in 2D plane above the substrate. So I am taking this 2D plane and I will rename it as patch. Edit the color and go to create rectangle. Size for the 2.4 GHz antenna patch is 29.4 in X direction and 38 mm in Y direction. So I will take the starting point as -29.4 divided by 2 in X and -38 divided by 2 in Y direction and 0. Yeah, of course Z will be 1.6 mm here because we are designing the patch on the top of the substrate, and this will be 29.4 mm and Y will be 38 mm. So this is our patch. Now we have to give the feed to the patch. So we will design our feed. We will use here the microstrip line for the feeding. So we know for FR4 substrate the microstrip line width is 3 mm. So we will design a 3 mm width rectangle to give the feed to antenna. Rename it as feed, change the color. Now we will go to create rectangle, and I will start it from 0 minus 1.5 and 1.6, and X size will be 30 to match the size of the substrate, and Y size will be 3 mm. So this is our feed line, but this feed line is of 50 ohm impedance, and as we know the age impedance of this patch is approx 250 ohm, and it will not be matching with the feed line. And when we move further away from the edge of the patch, the impedance decreases. So we need to find the 50 ohm point in the patch, and we need to connect this microstrip line to that point. We have calculated the values for that point, and we need to cut a rectangle from the patch. So I will design a patch. This is cut, and the dimensions we have taken is Z will be 1.6 and 14.7, Y is minus 2.5. This is starting point, and X size will be, and Y size will be 5 mm. Okay, sorry, here we need to give minus 9.5. Yeah. Now I will cut this rectangle from the patch. For that I will select the patch and control, and then cut, and then go to subtract and click on subtract. So this will cut that rectangle from the patch. Now at this point the edge impedance of the antenna will be 50 ohm, and it will be matching with the feed line. So I will connect the feed line at that point. So click patch, then control and feed, and then unite them. So our antenna is ready. This is our ground, and this is substrate, and this is patch. Now we have to give excitation to the feed line. For giving excitation, I will take one rectangle, and will change the plane to the YZ plane. I will draw it. Change the name to port, and go to create rectangle and change this width to 3 mm, and right click on port and assign excitation. I will assign lump port. Next 50 ohm and new line, then click on the triangle, and then again on upper surface, again on triangle. Next finish. We can see the excitation from here. This is our excitation. We have assigned material to the substrate, that is FR4, but we have not assigned material to ground and patch. Ground and patch are typically of copper, but we cannot give material to 2D planes in HFSS. So we will assign boundary perfect E, that is perfect electric conductor, PEC boundary we will assign. I have assigned the boundaries, that is perfect E, for ground and patch both. Now we need to give one radiation box which should surround the whole antenna. So I will design the radiation box and I will rename it rad box, assign material air, okay, and change the transparency to 1. Go to create box and start from -40, -40 and -20. And give X size 80 mm, Y size 80 mm and Z size 40 mm. So we can see the radiation box is surrounding the antenna. Now we need to give radiation boundary to this radiation box. We will give radiation boundary. We can check it from here. So this is our radiation boundary and this is our perfect E. So I have designed the antenna, we have created the model and we have given all the boundaries. I have given the excitation. Now we need to give the analysis setup. So right click on analysis set and add analysis solution setup. Solution frequency we will give as 2.4 GHz and maximum number of passes I will give as 20. Now right click on setup and add frequency sweep. Change the sweep type to fast. Start from 1 GHz, stop at 3 GHz and step size we will take as 0.01 GHz. So it will display the frequencies. So, okay. Now we have given the analysis setup to simulate the antenna and we will validate the antenna structure. So everything we have given, everything is okay. Now we will simulate the structure. Click on analyze all. It will simulate the antenna structure. The structure is simulated and now we will go to results. Right click on result and create model solution data report. Click on rectangular plot. To check the resonance of the antenna, we need to check S parameter, that is S11. So it's already selected S parameter S11 and in dB. Click on new report. Right click on plot and go to marker and add marker. Now end marker mode. We can see the resonance frequency is 2.39, that is approx 2.4 GHz. So this antenna is resonating at 2.4 GHz. Now we will plot the radiation of the antenna, how the antenna is radiating, in which direction, how much it is radiating. For that we will give far field setup. Right click on radiation and insert far field setup and then infinite sphere. So it's already 0 to 360 and step size is 10 for 5 and theta is 0 to 180 and step size is 10. So click OK. Now go to result, right click on result and go to far field report and 3D polar plot. So these are the functions we can plot. I am plotting the electric field here. So click on new report. This is the radiation plot of the antenna, 3D radiation plot. We can see it on antenna by going to the design, click on HFSS design and right click here on this plane and go to plot fields and then radiation field. This window will pop up. Just tick this box, this is visible, and apply. Close it. Now rotate it and you can see how your antenna is radiating. So maximum radiation is in the Z direction. We can see it here. This is x-axis, y-axis and z-axis. So maximum radiation is in the Z direction, z-axis. And this is our 3D radiation pattern. This is phi and this is theta. We can plot the radiation pattern in E plane and also in H plane. So we need to find what is the E plane of the antenna and what is H plane of the antenna. For that, just I will delete this one, this field, go to 3D polar plot and delete it. Now right click on the patch, this is perfect T and this is patch. Right click on the patch and go to plot fields and electric field, select vector E and here select all objects. It's done. So it will show the electric fields. I will change the scale here. So I will use the limits. Minimum I am giving 0 and maximum I am giving 8000. I will apply it. So you can see the electric fields here and you can animate it by clicking on the field overlays and then on electric field and vector E, just right click on vector E and animate. Just click OK. It will take some time and it will animate it. So you can see the movement of the electric field. And we know E plane of the antenna is that plane which contains the electric field lines and the direction of maximum radiation. So this electric field is moving in XZ plane and the direction of maximum radiation is Z axis. So E plane will be XZ plane. Now I will close it. I will go to radiation and then infinite sphere and I will change it because X is phi and this one Z is theta. So XZ plane will be for XZ plane phi will be 0 and theta will be varying from 0 to 360 degree. Step size I have taken as 10. Now go to results and go to create far field report. Click on radiation pattern and I am plotting the electric field. Click on new report. Now this is radiation pattern in the E plane. Similarly, we can find H plane and we can plot the radiation pattern in the H plane. So now we will find where is our H plane. I will just delete this E field. And go to HFSS design Raven model. Now we need to plot our H fields. So right click on patch and plot fields and go to H and then vector H. Select all objects, done. So this is showing the magnetic fields. This YZ plane will contain both the magnetic field lines and the direction of maximum radiation. So our YZ plane will be H plane. Now again go to infinite sphere and for setting it in YZ plane, the phi for YZ plane will be 90 degree and theta will again vary from 0 to 360 degree. Step size we will take as 10. Click OK. Now go to radiation pattern, delete it and go to result, far field, radiation pattern and now this is theta, new report. So this is plot in H plane. Now we know our antenna is radiating maximum in the Z direction. So gain of the antenna will be maximum in the Z direction. If we want to plot the antenna gain versus frequency plot, then we have to set the infinite sphere phi is equals to 0 or 90 we can set. I will take 0 0 0 and theta at 0 degree, because at theta equals to 0 degree the radiation is maximum. And then go to setup and click on sweep and change this sweep type from fast to discrete and this step size I will check the gain at every 0.2 gigahertz. I will change it to 0.2 and click OK. Now go to results, right click on result and create far field report and rectangular plot and go to gain. Here select gain total and in function select dB. Here we need to change this solution from last additive to sweep and this primary sweep type from theta to frequency, because we are plotting the gain versus frequency plot. Click on new report. It will not show, so we need to simulate it again. Simulate it. Simulation is completed and we can see maximum gain is at 2.4 gigahertz. Just I will take one marker. So maximum gain is 2.9 dB and it is at 2.4 gigahertz. So this is all about antenna design and its analysis by HFSS. Thank you.